And thanks for giving us the opportunity on behalf of Dalmia Group. Here, myself, Gaurav Patel, and my team member, Mr. Anand Pratap Singh, is also present here. So, starting for our Dalmia AFR journey, usage of alternative fuel is one of the important lever to achieve the carbon negative commitment. We have been advanced towards 2040 goal and made a capital expenditure of around 200 crores towards infrastructure of co-processing. Last year, we had consumed around 0.22 million tons of hazardous and non-hazardous waste consisting of RDF and plastic, paper mill plastic and MLP plastics. This year, YTD around up to October, our group average, entire Dalmia group average TSR is 11.8% TSR. And we are also pledged that we'll be using 100% of plastic generated will be consumed from local ULBs in next 4 years. So this is our AFR journey, our passion or vision, we can say. Moving ahead, if we say for journey in 2019, started our TSR was 3.9%. Then we moved on. By end of FY20, we had installed a imported shredder by like December 20. We had installed an important shredders. Earlier, we were having only Indian shredders, wave feeders, which I can say was in very crude manner. We are utilizing the AFRs. We had increased the TSR from 3.9 and our up to October it is 11.8% TSR. And by March 2022, our TSR target or will be achieved for our entire group would be 20% TSR. And if we see for our like 11 kilns, we are utilizing AFR. And if we see by kiln wise, most of the kilns are 10% plus TSR. Wherever there are less than 10% TSR, we are facing a challenge like what earlier presenter has also informed that the main challenge for increasing the green fuels is the chlorine content. So in two of our kilns, we have been hit by the chlorine content. Also because the product portfolio there is not demanding us to increase the chloride for that particular plant. So this is the reason. So for that, we had made an investment, will be going for the chlorine bypass system, which will be commissioned by next month by December and January 22 in two of our locations. So from there, we'll be achieving 35% TSR for that two kilns and reaching our target for 20% TSR. So like various technologies available, we had seen for size reduction, there are shredding. For separation, we have to also do the metal separation or else will damage the refractories inside our calciners. Impregnation is always required to co-process the hazardous waste. So by mixing of biomass and sludge material, this is important. And there are other methods like thermal preparation where drying and gasification of AFRs are also done. So this way we'll be getting the useful quality and quantity of heat, full quality and quantity of green fuels or AFRs for the co-processing in our kilns. So available technologies are pre-processing, two shaft shredders, granulators, star screen for metal separation, like size separation. So for Dalmia, we have two sub separators, Matso and Sitsa shredders, and star screens at all our locations for size separation. If we go for technology available for co-processing, we have shank systems or ATS extractors for consistent feeding and for feeding to calciner, double flap systems or rotary valves. So we have ATS extractors installed at all our locations. If I can say that we are having fluctuations only of 0.5 to 0.6 tons per hour with respect to the set point. We have installed double flap systems, ATS double flaps with 5 seconds operation time. But ATS flap, double flaps, I can say is like reaching 15 to 20% TSR is suitable. Beyond that, we should go for rotary air locks because to avoid the batch feeding of the material going into the calciner. Once we increase the TSR, tonnages will increase and these flaps then will be working as a batch operation and will feed the material in batch process. So this is the facility installed in DCBL where this imported shredders, then the magnetic separator to avoid the damage of refractories in calciner on the feeding locations. Then there are the star screen. Whatever material is there, we have been shifting to ATS extractor and then double flaps and feeding to calciner. So total 8 kilns have been installed with AF facilities and total 9 number of imported shredders like for 25 tons per hour capacity with screens have been installed in our DCBL. Further, if with this system, like we say that increase of AFRs will increase our heat consumptions, will increase chlorine, thereby increasing the pressure drop, which will reduce the clinker production. So consequences are there and we have to find the solutions to avoid the impacts. And we also have to find the solutions so as to we don't reduce the kiln efficiency or availability. So for that, our future planning is to aim to become by 2040 carbon negative and our TSR target of 20%. We are planning to install an additional shredder, mostly by like a secondary shredder, to reduce the size further from 70 to less than 40 of size, so that in the available calciner residents we can have the higher green fuel feedings. Additional feeding equipment, because ATS extractor is capacity of 25 tons per hour, we need to increase it further in order to cater the increase of heat consumption, increase of additional volume because of moisture. We have to upgrade preheater fan upgradation, calciner modifications are also planned. And in order to cater the chlorine management, we have been installing chloride bypass systems. So all these minimum things are required in order to achieve the group target or increase the TSR percentages, or increase the feeding of alternative fuels in our kiln. So in order to Pandey sir has already informed in the starting speech that yes, quality of heat is also important. So in our business, our main business is to manufacture clinker, and side by side we also have to feed AFRs. But there should be some criteria where we accept the materials based on our criteria, because lower the quality of heat, it will have negative impact and there won't be any savings, for which we are planning to use the green fuels. So we have been having a waste acceptance criteria for all the metals, mostly moisture, ash, flash points. So this way we have to manage our AFR business. Challenges are high moisture and ash. So we are planning, we are in talk with for installation of RDF dryers for reduction of moistures, exploring the system for separating the ash due to non-availability of good quality of limestones. And once we go on higher the TSR, our LSF requirement also will increase. So this is where we have to find a solution for extracting the ash. Chlorine content, yes, there's only one solution, is to install the chlorine management system, like chloride bypass system. Other is the consistent feeding. Even if we maintain moisture and ash within our criteria, but still the consistent feeding is not there, that will also have a negative impact on our system. And the granulometry is the size, so like proper maintenance of shredders, proper gap checking, these are also important in order to achieve our target of higher TSR. Next, if we see moisture, this comes from bio, since most of RDF comes from biomine site, there is open transportation of AF, there is lack of storage sheds at site and cement plant. So, and method of waste generated supply production depends on the supply to supply. So this will happen, it results in flame gas cooling, higher specific thermal energy consumption because of higher content of moisture, 40-45% also. And indirectly we have to handle more gas volume by the same preheater fan by maintaining the clinker TPD. So our mitigation plan is covered storage for AF inbound as well as the outbound material, whatever we had shed, that also has to be covered. Modifications we've already planned, replacement of preheater fans, drying of AF with help of waste gases, and negotiation for maximum water content or penalties. Like if the moisture content is increasing, we have to have penalties from the supplier to pay us more in order to cater the higher moisture content. Ash is also similar, like majority biomine site and dumping loading techniques increases the ash percentages. This will also have impact on energy consumption. And major impact what we have is we have to purchase high grade limestone if particular quality limestone is not available with us. And ultimate result, if we don't maintain the quality, then there will be a production of oxpack clinker. So this is not the our aim. So mitigation plan is like proper pre-processing at source by installing of trommels, wind shifters, ballistic separators. Main thing is that raw mix optimization to cater ash and maintain good quality of clinker. Proper green fuel blending, if we have the variety of green fuel AFRs available at our side, we should mix properly to have at least 1 or 2 days of feeding heap available, so that there won't be fluctuation in ash, moisture, CV, and in order to maintain the process stability. And selection of state of art burner technology to separate the ash, so that only the flame or only the heat goes into the system and ash is separated through that burn. Chloride, yes, the chloride, we are maintaining chloride limit. Global standard is 300 grams, but we are slightly higher on it, like around 400-500 grams chloride per ton of clinker. Chloride has the disadvantages of blocking our cyclones bottom stage. So to avoid the chloride, there are three systems available. One is the proven technology, which is gas bypass, around 15 to 20 crores of investment, and we have been planning to install in 2 of our locations. There is other also hot mill extraction, which will give only like additional potential of 200 grams increase of chloride, which will extract the material around 1 to 2 tons per hour from the bottom stage cyclone hot mill. So this way we can increase chlorine potential to 200 grams. Another is the kiln dust extraction, like in the direct mode of operation, whenever there's a raw mill off, we extract the gases from baghouse and don't mix it in into the homogenization silo. So this will also give us around 100 grams of chlorine target, potential target to increase. Another is last as yes, chlorine concentration to be agreed with waste generator and cost tag to chlorine concentration. Like moisture, we should also have it on chlorine. Chlorine, higher the tipping fees in order to have the ROI working for this gas bypass or any chlorine management system installations. And for this, like we are every 2 hours, we are taking sample from the co-processing feeding belt. Once in a shift, we will do the analysis for the moisture, ash, chloride, and we are also having an online in the DCS. We had incorporated Tom Lewis curve, like earlier presenter has said that they are maintaining to easily detect before they detect the if a blockage is going to happen or not happen. So this way, these are all the process optimization methods we had explained to our CROs, who are the main persons operating this green fuel business. Consistent feeding, yeah, reduce dosing fluctuation, reduce the benefits of all hard work done to reduce moisture and ash. Whatever we had reduced, hard work done for moisture reduction of moisture and ash, if our dosing fluctuations are not there, if dosing fluctuation is on higher side, then all this hard work is washed off. So less dosing will process instability, cooling of flames. So dosing fluctuation can be minimized by maintenance of feeding equipment, tuning of feed rate controller, or upgrade of weighing system. Like ATS extractor is latest to what we are having. Earlier we were having wave feeders which were having dosing fluctuations, and now with installation of ATS extractor, we are able to eliminate this inconsistent feeding. Other granulometry we can see, like it is always better for the process engineers or the production guys to say that yes, give us the lesser size material. Smaller the size will better with the combustion. But if in the AFR business, if it reduce this size, that will have the negative impact on the cost of that material. So we have to see win-win situation for savings as well as the process condition. So for calciner, we can say that around 80 to 40 size is possible. If my calciner is able to handle 80 to 60 of size, we should shed only to 80 to 60 of size, not to 40, because that will eat away our savings in terms of preparation and handling. So the key message is that for better combustion and green fuel maximization, minimize green fuel fluctuations, we should always respect chlorine input, price penalty for high or varying chlorine, and smart cleaning, installation of blasters. Like wherever it is possible, instead of manual cleaning, we should install a blaster in order to have the online cleaning and regular cleaning, and upgrade of exhaust and handling system to avoid production loss and minimize CO generation. And review of raw mix is required with highest inputs by AF. So this is most important point for maximization of green fuels. Thank you from my side. So this is what we never give up for to increase the usage of green fuels. We have to always fight the challenges.